11.4 or 11.3 is shapes of distributions, and we've talked about some of this already. But a couple things you need to know. First, a histogram, a frequency table. You probably also need to know what a stem and leaf plot is. Okay, those are all things that you may want to define once you're done with this lesson here. Okay, so you can come back to it. We talked a little about this. I referenced it last week, but I'll cover it again. Data, when you have data plotted in a bar graph or a histogram, and that data is skewed to one direction or the other. In other words, it's not symmetrical. Okay, when it's symmetrical, you have an even tail on both ends. The data is kind of cut in half. You get this nice line of symmetry. It's a reflection of each other. Whereas when it's skewed to the left, the tail or the lower bars or the longer tail or the longer whisker on a box and whisker plot would be to the left. If it's skewed to the right, the longer tail is to the right. Okay? So most of the data is laying to the left then if it's skewed to the right. So really when you're talking skewed left or skewed right, it's kind of weird. I've always thought it is kind of backwards, but we're referencing where the tail is. Okay? If the tail's on the left or on the right, it's skewed right. If it's on the left, it's skewed left. Okay? That means most of the data lies to the other part of the graph. When most of the data is right in the middle, and you don't really have a big noticeable difference in the tails on either side, then it's symmetric. Okay? Make sure you note that it's an approximate mirror image of each other. It doesn't have to be exact. Any questions there? Okay. Let's go ahead and turn to page 342. So what we do when we're trying to describe or figure out which measures to use, which of our measures of center to use, or other data measures that we've had, or measures of variation to use, or measures of spread, or any of that stuff, we're trying to determine first what type of graph it is. If the data is symmetric, like this, we use the mean. The mean is a good description to help us figure out or to evaluate this data. We use the mean, and then we use the standard deviation to describe how far away from the mean points are. So if it's one standard deviation away, we can add a certain amount to the mean or subtract a certain amount of mean. We'll talk about that today. When the data is skewed either to the left or to the right, we use the mean, we use the median to describe the center. Okay? Because the median is more in the middle of the data. Okay? We wouldn't want to use the mean there. Okay? We also use the 5-number summary. Now, when did we see the 5-number summary? When did we come up with 5 numbers to create a graph? It was on 11.2. Yeah. Yeah, with the box and whisker plot. Remember, the 5-number summary is your minimum, your maximum, your median, your lower quartile, and your upper quartile. So this is the median of the lower half of your data, and this is the median of the upper half of your data. That's what we did in our last lesson there. Okay. All right, I want you to tell your neighbor when you use the mean and when you use the median to describe your data, please. Okay. Hey, let's go ahead and take a look at the bottom page 342. It says, the table shows the average annual snowfall in inches of 26 cities. Describe the data in a histogram using 6 intervals beginning with 15 to 28. How many of you know what a histogram is? Give me what is a histogram really similar to? Yeah, it's very similar to a bar graph. A histogram is a bar graph with intervals describing the bars. Okay? So rather than having just a set item describing the bar. So if we're trying to make a histogram here, we want to set up intervals, and they tell you 6 intervals beginning with 15 to 28. So they're telling you the first interval has to go from 15 to 28. That means your first bar would be 15 to 28. Now, if your first bar is 15 to 28, that takes up how many numbers? 15 to 28 has a range of 13. So the next interval would start at 29, and it'd have to go to, at 13, we get 42. So to make it so that we're not misleading this graph, there's a couple things that have to happen. First, our bars have to be the same width. Second, your intervals have to be the same amount. Otherwise, you're misleading when you're doing graphs. Now, in order to figure out how high we want to go on our histogram, they tell us where to start. It's at 15. I would hope that's our minimum. To figure out how high we go, we need to figure out our maximum here. So what is the maximum? 54? Nothing else? Yeah, there's that 95. It's like an outlier way out there, right? Okay, that means we have to go all the way up to 95. Which means we have to keep making intervals of 13 all the way up to, or sometimes it doesn't go exactly to 95. I know in this case it's not going to hit 95 exact, so you have to go at least over 95. Okay? So I want you to finish up your histogram there. This would be frequency over here, by the way, meaning how often it occurs.
So 43 and 56. And 57 and 70. 71 and 84.
Put your intervals, and then once you get your intervals, go ahead and get the bars in there. Yeah, frequency would be how often it occurs.
And how often the number occurs?
Mm-hmm. So, yeah, how many numbers are between 15 and 28? So, like, one thing that would help out on this, because this data is really, it's not organized really well. How many of you have heard of a stem and leaf plot? Okay, stem and leaf plot takes all the first digits, like all the tens, if we're below 100 here. Okay, so if I think of it that way, that I would have 10, 20, 30, 40, 50, 60, 70, 80, and 90. You guys with me there? Okay, and then those are my stems. And then to put the data in a nice, orderly fashion, what I can do is say, okay, well, there's a 22, so I just put 22. There's a 15, so 15. There's a 20. There's a 25, or excuse me, another 15. There's a 44. There's a 95. There's a 29. There's a 37. There's a 16. 68, 28, an 18, a 54, a 43, a 41, 23, 30, 33, 31, 30, a 16, a 17, a 30, and a 47, and a 54. Okay, so I have all my data in that stem and leaf plot now, which makes it a lot easier to figure out where the data is. If you want it even better, and usually when you're making a stem and leaf plot, you put the data, once you have it, these are all the 40s, you put it in numerical order. So you got a 1, 3, 4, and 7. So I'd write it as 1, 3, 4, 7. Okay, and I got 0, 0, so 3 zeros, a 1, a 3, and a 7. we have a 02389. And 55, these are almost in order. So 6, 7, and 8. Okay. So now I have all my data in a format that makes it really easy to look at. A lot easier to figure out. So if I say from 15 to 28, that takes up all the 10s, plus all these except for the 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. I'm probably going to want to go up by, I would guess, 2s here. Go 2, 4, 6, 8, and 10. Okay, so if my frequency I had 11 with my first count. Did I miss a number up here? Where am I missing a number? Should I have another 26? Okay. Oh, I don't have a 26. That's a problem. Good find. All right. So we've got 11 there. So we go up to 12. So 11, that would be our bar. And done. Okay? So finish up your histogram there. So 29 all the way to 42. So that's 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. Thank you. Sometimes it's helpful above the bars to put how many numbers. So there's 11. This one's 8. You don't have to, but it's a nice piece. So 43 starts right here. And so 1, 2, 3, 4, 5. I'm going to 56, so just 5 of them. And then 57 to 70, so just 1. '71 to 84, there's nothing. And then 1 from 85 to 95. All right. So go ahead and answer questions B and C there. I'll be around to help out if you. Hey, you guys, which way is this data skewed?
Right.
Skewed to the right. The tail's at the right. Okay, so there are 2 measures you need to worry about. Measures of center and measure of variation. Okay? The measure of center is like mean, median, and mode. Okay, measure of variation, measure of center, mean, median, mode. Measure of variation is standard deviation. It's also range. And it's also the 5-number summary. Okay? So when I'm calculating this, if this is skewed to the right, do I use mean, median, or mode?
Median.
Yeah, we use the median because that's more the middle. Okay? And do we use standard deviation or the 5-number summary? You don't use the range there. 5-number summary. The reason why is because it's skewed to the right. What's that?
Wouldn't this be the graph? It'd still be medium, but
Yep. Yeah. We use the median in the 5-number summary because the data is skewed to the right. Okay. The weather station lists the top 20 snowiest major cities. The city is 20th. The city in 20th place had 51 inches of snow. How would you interpret that data? So if the top 20 cities, if the least snowiest of those top 20, the one that had the least amount of snow out of the top 20 had 51 inches, what could you say about most of these cities?
That they're not in the top 20.
Yeah, they didn't make the top 20, man. They didn't make the cut, right? Like all these cities down here,
Oh, snap.
right? They didn't even get there, man. Okay?
I don't even like snow.
Yeah, so most cities were not on the list.
It's nice for a while, and then you get sick of snow, and you're like, I want it to be summer.
I kind of like snow.
Dude, I got so.
You just
over
want snow day.
snow.
I want to go sledding.
I was so
I've never
over
had a
snow
snow
during
day.
the winter.
I've
We
never
went to Leavenworth,
laid in
and I was
snow.
like, snow for a
What?
day.
walked in snow, never played in it.
Oh. See things we take for granted? Sorry, Genius. All right, everyone take a look at number 3. Hey, no drawing graphs here, just interpreting them. So, double histogram.
Oh, there's a river bank.
That just means there's 2 of them.
I thought it was
Pay attention. Shows the distribution of monthly participation or precipitation for 2 towns over a 50-month period. Compare the distributions using their shape and appropriate measures of center and variation. Okay, so use your information from up here for both graphs, and then go ahead and come up with a comparison based upon that information.
Do you know it's 5-number summary?
If it's skewed to the right or left. How would you actually figure it out? You'd have to take the data. You have to extrapolate the data. So you'd have to pull out, say like this is a this. Okay. It's something we're not going to grab from
the
this.
rat living in it.
Okay, hey, taking a look at this data, what can you tell me about City B compared to City A?
It rains more in the middle.
It's symmetric.
Yeah, well, it looks more symmetric. City A is skewed to the
Left.
Right.
Left.
skewed to the right. Okay. Hey, I need everyone focused. Okay. What can you tell me about City B compared to City A in terms of precipitation? Yeah. It rains more often in City B than in City A. Yeah, they have more precipitation here than they do here. Okay.
They do.
Yeah, getting higher, you're getting more rainfall. And this bar and this bar, right? This is 8 to 11. This is 12 to 15. So our graph is shifted.
See, I was
Here.
just reading the graph.
Yeah. So we get more. City B has more. Usually has a greater monthly precipitation than City A.
Now I get what I thought was wrong. I thought it was like months of the year, but then I realized it goes to 23.
Yeah, it wouldn't make any
It's not
sense. Yeah.
23 months a year. Or is that 23? What number is that? Must be 3. Yeah.
Okay. Can we tell anything else from that? What's that? No. So City B usually has a greater monthly precipitation, and it kind of differs quite a bit for City A, right? I mean, they could have 0 to 3 inches and all the way up to 20 to 23 inches. Okay, so they have a greater range than city B does. So city B has more range. City A has a greater range in the amount of rain. All right. Hey, let's go ahead and take a look at one last piece here. I want you to try number 3. So make a double box and whisker plot for this information. Then describe the shape of the distribution. Answer questions B, C, and D there.
Hey, Mr. McCoy.
Yeah.
You know the recognition thingy for like the math that I got?
Hold on, let's talk over here in a minute. Hey, guys, that would be look at the box and whisker plot. It doesn't have to look exactly like this. Some people put one above, one below the number line, but that's what we've got. Notice the females are more symmetric in terms of the box and whisker plot, where the males are skewed to the left a bit. Okay. So if we're comparing the number of hours of music listened to by females and the number of hours listened to males, the number of hours listened by females tends to be less than the number of hours listened to by males. Okay. Notice the males listen to more because the median is higher. The first and third quartiles are higher. Okay, or we call that the lower and upper quartile, the first and third. And about how many females surveyed would you expect to listen to between 22 and 34 hours? So here's the big deal. This is how you start interpreting your data a bit. Okay, 68% of the data is within one standard deviation from the mean. Okay, let's say that again. 68% of your data, when you have a symmetric display of data, 68% is within one standard deviation from the mean. Okay? So meaning that if 68% of the females, 68% of the 50 females would give us 34 females there. Okay, I want you to talk about what this means here for a minute. Figure out what standard deviation, how they're coming up with this amount. All right, this is going to be the most confusing portion of this lesson for you. At least that would be my guess. Okay, so talk about part C there with your groupies. Study hard and work hard. Okay. Hey, ladies and gentlemen, this is what we're talking about. If you have symmetric data, and I want to be done with this lesson, so I need you guys to focus up here. You have symmetric data. This line right here represents our mean. Remember, this would be this picture that we talked about earlier. Okay, the way standard deviations work is if you are one standard deviation away, that represents, so this one is one standard deviation. This is probably something you want to copy down somewhere. Okay, one standard deviation away from your mean in symmetric data represents 68% of your data. Yes. Always. 68% of your data is represented with one standard deviation away. You guys see that? Okay? I'll give you a chance to copy that down there. 98 or 95% of your data is within 2 standard deviations away. Okay? So if you can find your mean, 68% of the data is going to lie within 1 standard deviation of the mean if the data is symmetric. So if you look at your graph and you go, hey, that's a symmetric curve, 68% of the data will be within 1 standard deviation. Okay? Two or excuse me, 95% of your data will be within 2 standard deviations on that.
Questions.
Is it a serious question, Sarah? Yes. Yes, it's a standard deviation on both sides of the mean. Okay? So what if you're try to fit them both? I can't fit them. I can, I guess. Okay. In this data, they tell you that for females is the only one that this works for because it's the only symmetric. This one's not symmetric. It doesn't work for the males. Okay? But for the females, it's saying the mean is 28. So if this is 28 and your standard deviation is 6, that means if we add 6, that brings us to 34. Or if we subtract 6, that brings us to 22. That means 68% of our data will be between 22 and 34. And that's what's being asked right here. That's what they're saying. How many female survey would you expect to be between 22 and 34 hours? Well, 68% of the 50. Okay? That's from the 22 to 34. That make more sense? So then it says, if you survey 100, this really should say 100. I get rid of the word more. Okay, if you survey 100 females, actually, you know what, let's leave the word more in there, that's fine then. Sorry, if you survey 100 more females, about how many would you expect to listen between 16 and 40 hours? Well, 16 to 40, notice, this isn't 16 to 40. So if I move another 6 this way, which is another standard deviation, I'm at 40. And if I move another 6 this way, I'm now at 16. So I'm now at 2 standard deviations away from the mean, meaning I am 95% of the data now. So 95% of 150 students. So in that case, it would be 143 females are 2 standard deviations away. Yeah?
Is 100% of the data within 3?
No, because it's a bell-shaped curve.
So it doesn't.
So when you start studying statistics, like if you keep going in math and you get up to studying statistics, you'll be spending a lot of time studying this type of data.